Vectors, page 16. Um, so for 12I parallelism, page 304 reading, two non-zero vectors are parallel if and only if one is a scalar multiple of the other. Scalar multiple of the other. If A is parallel to B, then there exists a scalar k such that vector A is equal to k vector B. If A is equal to k vector B for some scalar k, then A is parallel to B, and length of A is equal to k times this length of B. Unit vectors. A unit vector in the direction of V is length, 1 over the length of V times vector V. A vector B of length k in the same direction as A is B equal to k over length of A times A. A vector B of length k, which is parallel to vector A, could be B equals so it could be, in this case, it would be like plus or minus, right? Because it's parallel to, but it's not necessarily in the same direction of. Okay? Let's see. Number 1, A. So we have two vectors, A and B, are parallel. Find R and S. Let's see, if they're parallel, that means that basically that vector A is equal to k times vector B, and so vector A would be, and k is a positive or negative number in this case. So that would be 2, negative 1, 3 is equal to negative 6k rk sk. So that would be negative 6k equals 2, negative 1 equals rk, 3 equals sk. So here k is equal to negative 1/3. Also, we've already solved for k, but we need to find r and s. So for this one, we have 3 equals sk. So we know that 3 equals k is negative 1/3, so it's 3 equals negative 1/3 s. So s is equal to negative 9. And then for this one, we know that negative 1 equals rk, so negative 1 equals negative 1/3 r. And then we multiply both sides by negative 3, so we get 3 equals r. Okay, and k equals negative 1/3. All right. What can be deduced from the following? Vector AB is equal to 3 times vector CD. We could say that AB and CD are in the same direction. Same direction. Okay. Vector AB is equal to 2BC. So vector AB and BC are in the same direction. And we could also deduce something about their size too. Oh my god, this handwriting is terrible, isn't it? Very hard to write with this stylus. Okay, if vector A is equal to 2, 4, write down the vector in the same direction as A and twice its length. Same direction as A and twice its length. So then you would have 4, 8, right? In the opposite direction to A and half its length. So it would be -2, -4, but it would be half of that, so it would be -1, -2. Now for 7a, they want a vector in the direction 2, -1 with length of 3. So let's see, what is the length of this vector here? It would be 2 squared plus 1 squared square root, so it would be square root of 5. So we could take this original vector 2, -1, and we could divide it by the square root of 5, and that would give us a unit vector. And then we would multiply this unit vector times 3, and that would give us a length of 3. Okay? Same thing with this one. So if we start with a -1, -4 vector, what is the length of this vector? It's 1 squared plus 4 squared square root. So that would be square root of 17. So we divide by square root of 17, and we multiply by length of 2. Okay, so that would be 7b. 9a. Find the vectors of length 1 unit which are parallel to vector A. So this would be length of 1 unit which is parallel to vector A. And it says find vectors of. So there would be at least 2, I guess. So let's find 1. So what would be the length of this vector? It would be 2 squared plus 2 squared plus 1 squared square root. That would be 4 plus 4 plus 1 square root, which would be 9 square root. Oh, that would be 3. So the length of this vector is 3. So we divide by 3. Okay, and that would be the unit vector. Okay. Now they say what are the unit vector, or what are the vectors of length 1 which are parallel to this? Well, one of them is this, and the other one would just be the opposite direction, which would be -1/3 times that. Okay. Find the vectors of length 2 units which are parallel to vector B here. So let's see. Let's find the length of this vector. So it would be 2 squared plus 1 squared plus 2 squared. Hey, it's the same as before. It would be length 3. So we would just do 2/3, -2, -1, 2. We divide by 3 because the length is 3. And then we multiply by 2 because we want the thing to be length of 2. And then we just multiply by negative to get the opposite direction, because we want 2 vectors, one in the same direction and the other one in the opposite direction. Now I'm thinking back to here. It says yeah, and I think I got let's see. Okay, if A equals KB for some scalar K, then A is parallel to B. Yes, okay, I think that's all right.